Hi there guys, how are you doing? This is your friend and tutor Manas, and today we are going to be continuing with our discussion on projection of planes. So let's see what the problem has in store. Here we go. Well, it goes like this. Draw the projections of a regular pentagon of 25 mm side, having its surface inclined at 30 degrees to the HP and a side parallel to the HP and inclined at an angle of 60 degrees to the VP. Okay, now that we have read the description, let's extract data. The first thing to note is that the object in this case is a regular pentagon. All the sides are 25 mm each. Okay, apart from that, if you read carefully, surface is inclined at 30 degrees to the HP. Now, if there is something which is inclined to the HP, we have to denote that by theta, and theta is for surface. So theta surface is equal to 30 degrees. Okay, theta surface is equal to 30 degrees. Now there is one more condition which says that side is parallel to HP and inclined at an angle of 60 degrees to the VP. So the side which is parallel to the HP is also inclined at an angle of 60 degrees to the VP. So any sort of inclination with respect to VP is denoted by phi. Phi side or phi edge is equal to 60 degrees. Alright. Now as far as the solution to this problem is concerned, I have divided that into two parts. Part 1 is where I'll be giving you a demonstration as to how the object has been really kept with reference to HP and VP. What shall be an initial assumption, whether we need to draw front view first or top view first. All these kinds of stuffs I'm going to be discussing in part 1. And then in part 2, we'll simply try to implement all those things that we've learned in part 1 into part 2 in the form of a drawing. So let's go ahead with part 1. So guys, this in front of us is a pentagonal plane of negligible thickness. Now, there are two important things which have been given to us. Number one is the surface inclination. So it's something like this. Surface is inclined at an angle of 30 degrees. 30 degrees. This is how much? 30 degrees with the HP. Okay. So our assumption for step number 1 is going to be this. We are going to assume that this entire surface is resting onto the horizontal plane. Okay. And then we just need to think from where can you see the true shape of this surface. Obviously, this true shape can only be seen from the top, and hence in step number 1 we have to begin by making the top view first. Alright, so this is going to be your top view. Okay, now if you watch carefully, if I can just draw this XY line, this is going to be the XY line below which we'll be making this top view. If you watch carefully, this edge over here, okay, has been kept at an angle of 90 degrees. Fine, why? There is a specific reason, because at the end, that is in step number 3, this edge will be making an angle of 60 degrees with the vertical plane. So I have told you in the previous problem also, whichever edge has to be inclined in step number 3, either with HP or VP, it initially has to be kept perpendicular to this XY line. Always remember that. Alright, so the assumption is like this, making sure that this entire surface is resting onto the horizontal plane. Top view, front view, this is step number 2. Okay, front view, top view, and this is going to be step number 3. You can make it like this. Okay, if you extend this from the top, you're going to see this angle over here. Okay, you can do it like this also. From the top, you're going to see this angle, something like this. It's absolutely based on your choice. So these are the 3 steps that we're going to be implementing right now. So let's go ahead and do that. Now that you have seen the demonstration, we'll now go ahead and try to make the projection of this particular case. Initially, we're assuming that this entire surface is resting on HP. In that case, the true shape of this regular pentagon can only be seen from the top. And we'll be beginning with top view. Okay, and this is how the top view is going to be made. Alright, let me have a protractor. Now the internal angle in case of regular pentagon is equal to 108 degrees. So this much is 90, this is 100, 105, 6, 7 and 8. That's it. Okay, you need to draw a line over here equivalent to 25 millimeters. Okay, same stuff has to be repeated over this side also. This is again going to be equal to 25. Angle obviously is 108 degrees. Okay, now you need to have a compass, and in that compass you need to take a radii of 25 millimeters. Then with this guy as the center, put an arc. With this guy as the center, cut this arc. You will be getting an intersection point which has to be joined with these 2 corners, something of this sort. And let me name each and every corner. A, B, C, D, E. That's what you're going to get. Let's try to take a look at this regular pentagon which is entirely resting on the HP from the front. Okay, and this is going to be its image, or this is going to be its view rather. That's the front view in the form of a line, simple line. Now guys, if you've watched carefully, this edge EA has been kept at an angle of 90 degrees with respect to XY line. Why have I done so? Because it is this edge which will be finally kept at a certain angle with respect to XY line in step number 3. That's why. Always remember, whichever edge or side is inclined in step 3, it has to be kept perpendicular to XY line in step number 1. Always remember this. Now, as far as step 2 is concerned, we have to go for surface inclination. In this particular case, the surface is inclined to the horizontal plane. Just think about this. If the surface is inclined to HP, then obviously that particular angle can only be seen from the front. And hence what we're going to do is, we'll incline or we'll recreate this front view over here at an angle of 30 degrees, that is theta surface. So let us do that. This is going to be point A dash comma T dash. Let me make a line right now at an angle of 30 degrees and let me recreate these points B dash comma D dash. Now with this much amount, please see where the cursor is, with this much amount as the radii and with A dash comma E dash as the center, I'm going to put an arc. This is going to give us B dash comma D dash. That's simple. With this much amount, please see where the mouse is hovering, this much amount as the radii, and with P dash D dash as the center, I'm going to put one more arc. That's going to give me point C dash. Now let us take a look at this inclined regular pentagon from the top, and this is exactly what you're going to get. These are the intersection points. Now this is the horizontal for A, this is the vertical for A, that's point A. This is the horizontal for P, this is the vertical for B, that is point B. Similarly, you can work out the remaining point, and when you join all of them, you're going to get this sort of a squeezed up pentagon. Okay. Now, what shall be done in step 3? Well, step 3 is meant for edge inclination. Okay, so what I'm going to be doing is, assume that this pentagon over here, apparent pentagon, has been enclosed into some sort of a box. Let us say that this is point 1. Let us say this is point 2. Okay, and let us say that this is over here is point 3, and this over here is point 4. What needs to be done is, this EA side has to be kept at an angle of 60 degrees with the VP. So any sort of angle with respect to VP can only be seen from the top. In that case, this top view has to be recreated over here, over to this side, making sure that this side EA has been kept at an angle of 60 degrees. So let me make a line at an angle of 60 degrees with respect to XY line. Okay, now I'm going to make this rectangle 1, 2, 3, 4 rectangle over here, something of this sort. Let me show you. This is 1, this is 2, this is 3, this is going to be 4. Now these 2 points, points E and A, are going to be here, something of this sort. Let me show you. This is going to be point E and this is going to be point A. How have I got these points? It's pretty simple. You need to keep your compass, one leg of your compass here, other leg over here. With this 1 as the center, you need to put an arc, and that's how you're going to get point E. Similarly, you can have point A also. Fine. Now, between point 2 and 3, we have point B. This is where you're going to have point B. That's it. Similarly, you have point C, and finally you have point D. And let us join all the points in sequence so that we can have this exact same pentagon over to this side. Now let us take a look at this from the front. Let me have the projector lines from bottom to top, and let me have them from left to right. These are the intersection points. Now if you want point A, this is the vertical for A, okay, and this is the horizontal for A. This over here will give you point A. Similarly, if you want point B, this is going to be point B. Alright, now let us have each and every point this way, and let us join all of them. This is the final projection. Alright, when the surface makes an angle of 30 degrees with the HP, and at the same time one of its sides incline at an angle of 60 degrees with the VP. That's exactly what you're going to see from the front finally. So guys, that was all from my side for today. If you've got any doubts or queries, do write them down in the comment section below. I'll be very happy to answer them. I'll be back with more such tutorials on prediction of planes and many more topics. Until then, it's a wrap. This is Manas Patnaik signing off. Take care, have a great day, and keep drawing.